Hello, everyone. So in this pre-lecture tutorial, I'm going to present a very quick example of how to use the combined gas law. As we were discussing the other day in class, it is possible for a chemical system that we are studying to not be sufficiently controlled so that only two of the four gas variables of state might change. It's entirely possible that three variables might change instead. And so, if you remember, basically we had derived that the expression that would actually encompass Boyle's law, Charles's law, and the Gay-Lussac law would look like this. Basically, P1 V1 over T1 is equal to P2 V2 over T2. And so let's actually show how you would actually use this particular law to solve a problem. In this particular problem, we're being asked to calculate the volume of a gas at STP. And so let's briefly describe what STP is. STP refers to standard temperature and pressure. Okay. And basically, standard temperature and pressure for a gas would be 1 atmosphere and a temperature of 273 Kelvin. And so the gas originally has this pressure condition and this temperature condition. We're being asked to calculate the volume. All right, if 502 milliliters of the gas are collected at 29.7 degrees Celsius and 96 kilopascals. And so basically this would be the second volume, okay? This would be the second temperature, and this would be the second pressure. Now, before we actually plug into the combined gas law, we should be very aware of our units. If you notice, basically, I've expressed standard temperature and pressure, particularly the pressure, as units of atmospheres, but we're going to have to work with units of kilopascals. And so what that means is, eventually what's going to happen is I'm going to have to take a pressure ratio in my solution to this problem, meaning I'll be dividing pressures against each other. And so in order for that to work out mathematically as it should, I have to make sure that the pressures are in the same unit. And so if you recall, 1 atmosphere is 101.325 kilopascals. We discussed that when we talked about interconversion of pressure units earlier in the chapter. And so I have to make sure to use this value of pressure instead of the one in atmospheres if I'm going to get proper cancellation. Now, the other thing I should consider, and again, this is more of my own preference, more so than the sort of absolute way you have to approach this type of solution. I prefer to solve for the variable that I'm looking for first with all the symbols in place and then only plug in at the end. So here's V1, okay? I'm going to try and create an equation using algebra so that I have V1 equals some other mathematical expression on the other side of the equal sign. And so obviously I'm just going to copy over P2 and V2, okay? But since this is essentially a proportion, I have to isolate V1 on this side. So that means I have to get rid of this T1. I can do that by multiplying both sides by T1. If I do that, essentially it has the effect of bringing the T1 over diagonally through the equal sign to the numerator on the other side of the equation. Okay. Now, in addition, basically I also have to get rid of the P1 as well. The way to do that is to divide by P1 on both sides. That essentially would cause the P1 to sort of travel diagonally through the equal sign to the denominator of the proportion on the other side. So that would be P1 times T2 on this side. Okay, now I'm ready to start plugging in. So basically my second pressure was 96 kilopascals. My second volume was 502 milliliters. My first temperature was 273 Kelvin. Okay. Then I'm going to go down into the denominator. My initial pressure was 101.325 kilopascals. And my second temperature was 29.7 degrees Celsius. But again, I have to make sure to convert that to Kelvin. So I would take 29.7 and I'm going to add 273 to that. And so if I go ahead and do that math, I get 302.7 Kelvin. So that's going to be my second temperature. Okay, so now I'm just going to do this math. I'm going to multiply 96 times 502 times 273. I'm going to divide that by 101.325 times 302.7. Okay, and if I do that, I get 429 milliliters. Okay, so that was the original volume when my gas was at STP. So again, answer the questions attached to this pre-lecture tutorial. Try to use this example problem as a model. And if you have any questions, by all means, go ahead and email me or bring up your questions in class. All right, have a good night.